Hello and welcome to the third practicals of Introduction to Structured Programming. Today I think we have really cool plan for the next hour.
Yeah.
So we will continue with problem solving, which Alex and David started, and then we will also go more deeply into C. So I think we go right into it. And meanwhile, while we start with some organizational things, you can already log into Menti. You should find the link in the info box of the YouTube video below, because we again have a recap quiz of the last practical session. Okay, so organization, what is planned for today, what are the important things? Coding sessions, so this week the first coding sessions took place. Which were, I think, really interesting for you as the students who attended them. For the next week, the pre-work is already available in the Teach Centers. You can find it there if you register to a slot. And do not forget the 4 steps that are required when you do the coding sessions. You have to register to one of them. You have to do the pre-work before your coding session. Then you attend the coding session, and then you fill out the form at most 48 hours after your coding session. So this is the first thing, and the pre-work for the third week will be released next week. Yeah, and another thing that also Alex and David announced before is the voluntary exercises, which are linked on our Notion website, and particularly because in the next 2 weeks there will not be a lecture here, and maybe it's a good thing if you start practicing C a bit. And there are some chapters, and the first 2 chapters are about data type operators, conditions and loops, and all of them are probably doable for you. There are, I believe, some challenges because we haven't explained everything there, but if you invest some time you should be able to do them, and then you really have a head start for November, where we really go into C.
Also, at the end of the stream, we'll probably give you some suggestions of what you could do with what you learned in the stream today, and how you could extend the examples we'll program.
So you can really practice a lot.
Yeah.
So I assume that everyone logged in now to Menti, because I think the next thing is the Menti Quiz. Okay, do you want to start with the first question?
Mm-hmm.
Okay, this looks already good. How many people are in the stream currently?
Okay, 200. So maybe wait a second.
Yes. Is there anything in the chat happening?
No, I don't think so. So of course there are no points for voluntary exercises, but yeah.
They're good practice. Okay.
Okay, then let's start. So it's just a recap about last session. And yeah, this is the first question. So the maximum value of either a signed integer or an unsigned integer is larger.
Everyone answering very fast. Looks really good.
I think this should be an easy question if you paid attention last time. Yes, so while both types can represent the same amount of values, an unsigned integer can represent larger values because it cannot represent negative values.
Mm-hmm.
Okay. So continuing to the next question. So how many different values can a char represent?
Also something we learned the last time.
So the options are 128, 255 and 256.
Some people are still thinking.
Yeah, it's 256. 255 is the maximum value, but you can also represent 0. So it's 256 values.
And that's because we have 8-bit and with 8-bit.
Exactly.
Yeah, we have 256. And why would be 128 an answer that somebody select?
So if we have a signed character, then 127 is the maximum value and negative 128 is the minimum. Okay, and I think that's the last question.
That's the last question for the recap.
Okay, so we have an integer a and an integer b. And what is the result for a divided by b? So we talked a lot, I think, about numbers in the last stream.
Maybe that's a bit like the hardest question.
Yeah,
now.
I think so. I tried to get them more and more difficult.
And also the last people answered.
Yes, it's 1 because even if like 1.666 it would be the correct answer if we are talking about floating points. Because we are talking about integers, the last part is just cut off, and integer division just is always rounded down.
But I would like that the 2 selected exactly 42 students.
Yeah.
Okay, then we continue. And we want to show you now an algorithm, or actually we would like you to invent algorithms to solve a problem, and that's the problem, bin packing. So in general, we want to search for some easy problems and where we can explain an algorithm, and searching and sorting are like the most used, most popular examples here, and everyone knows some sorting or searching algorithm. So we decided to do something completely different, where we hope that you haven't heard anything about it yet.
So we hope the problem is simple, but you can still think about it and don't have any like ideas already.
Yeah. So let's start with the problem definition, and it might seem a bit tricky now, but we will show you then an example where it should be really clear for you. Okay, so what is given? So we have n items, and each of those items have a certain weight. And as we have n items, we can label the weights with W1 to Wn. So the item I would have the weight Wi. And in addition, we have this C, which is the maximum capacity of weight that can be placed into a bin. Okay, so we will create bins in this problem. And now our goal is that we assign each item to a bin such that no bin is overfilled. So if we sum over the weights of the items that we assign to a bin, it should not exceed this C. And we additionally want to minimize over the number of bins that we use. So a very trivial solution would be that we create n bins, and in each of those n bins we place exactly one item. Then we assume now that the weights are in such a way that they always fit into a bin. Then we would have a solution which has n bins, but maybe we can put together some items into the same bin such that the capacity is not exceeded, and we can save some bins to really get the minimum number of bins which is needed. Okay,
so maybe this was a bit abstract for you. So let's just start with an example. So let's suppose we have 7 items, and the weights of these items are 5, 8, 3, 6, 4, 2, 7. And one bin can carry a maximum capacity of 10. I prepared something.
Yeah.
A little drawing. So we have these items here, and also we have these bins down here. And as you can see, each bin can fit a maximum of 10, has a capacity of 10. So we could fit, for example, the item of the value 8 and of the value 2 in one bin, but then we can't fit anything. And now we want to find an algorithm and think about it of a way of how we could put these items into these bins so that it's efficient and we can minimize the number of bins we need to complete this task. I hope that made it a bit clearer.
So maybe in the chat, before you write your ideas, maybe a thumb up or a thumb down whether it's clear what you should do. Or in addition to the ideas that you're already writing here. So should I just read through the chat a bit, yeah, and read it out loud that we both get the idea. So there is the idea, for example, just make a loop for summing everything within. That was too fast. Just make a loop for summing everything within everything and compare our output values with C. Choose the closest. Okay. Always take the heaviest one and put it in the first available bin. Start with the biggest item, put it in the first bin, and put the others in the other bins in descending order. So we have like the idea that we sort them and then we start with the biggest item. Okay, again the same idea.
Yes. So ideally we would put the items in a way in the bins so that every bin, of course, is at its maximum capacity. So if we have like the sum of the items in each bin is 10, so the weight, then we know that we have an optimal solution, but of course we are not sure if such a solution even exists or how we could come up with such a solution. Yes. So we will look at a few algorithms now.
And I just want to mention that the ideas that you have are really, really good. And probably the idea that most of you had will be then our final solution. But we will start now with with a simpler algorithm, just to introduce it a bit to you. Okay. So this algorithm is called next fit, yeah, and I think we start by an example, right? So go back to the drawing mode.
Okay. So the idea of next fit is that you look at each item and place it in the, for example, first bin, and if you can't fit it in this bin, you choose the next one. And then you try to fit the next item in that bin, and if it doesn't fit, choose the next one. So this is really a simple algorithm where we just go over the items once and need to remember in which bin we currently are. So let's just create like an arrow so we know in which bin we are. So, okay, we are in the first bin now. So let's consider the first item here and put it into the first bin because that's how we said we should do it. Then we continue to the next item, which has a weight of 8 now. And if you try to put it in the first bin, we can see that it's too much. It doesn't fit. So what we'll do now is let's look at the next bin and put this item in there. Okay, so now in this bin there's 8 out of 10 like capacity used. So let's look at the next item 3, which again doesn't fit into the second bin. So we consider the next one and put the 3 in there. But now it gets interesting because the 6 now fits in this bin. So we don't need to consider the next one and can put it in there. Then let's continue to the next bin with the next item. These all fit in here. And then again, with the last item, the 7, it doesn't fit in this bin. So let's just put it in the last one. I hope this wasn't too fast.
I think it was clear, at least nobody complained in the chat.
Anything you would like to add? Or?
Yeah, so there are some observations in the chat already. It's not optimal.
No.
That's completely true. It's the fastest. Yes, that is true. So of all the algorithms that we will discuss today, this is the fastest one because we always consider just the current bin and maybe the next bin, but we do not go back to bins that we created previously.
Yes, so we don't need to remember how much we put in the last bin or anything. We just know, okay, in the current bin I already have that many items with that much weight. So if the item doesn't fit, let's just use the next bin. Yeah, so it's a pretty simple algorithm.
Okay, then we might switch to the pseudocode now. So I want to show you now how to formalize this algorithm a bit. And we will go through it step by step. And yeah, I will explain everything that we need. So the first thing that we have here is the input, of course. So we have those weights as the input and this constant C, which is the maximum capacity. And then we start with some bin. So we say we start with the first bin and we have a sum. Yeah, and the sum will always refer to the current bin that we have. And in the beginning, we haven't placed any items, so the sum is 0. And then we iterate over the items. So we start with item 1, and as long as we haven't reached n, yeah, we continue here, we loop over the items, and in each iteration we of course have to increase the counter. So in the first iteration we would have I to be 1, so we consider the first item, then we increase it to 2.
Now we start at 1 in this pseudocode.
Yeah, yeah, that's because I'm a mathematician, and in mathematics you usually start with 1 and not with 0. So then you increase it to 2 and so on and so forth, and at some point you increase it to n. N is still less equal than n, so we have a last iteration for the last item. Okay, and now the question is, what do we do within the iterations? So first thing that we do is we check whether the sum, so the sum refers to everything that's in the current bin by now, plus the weight of the current item exceeds 10. And if that is the case, we cannot put it into the bin because it doesn't fit. So we increase the count of the current bin. So we go to the next bin and set the sum back to 0 because nothing is in the bin at this point. And with this if statement, we have the guarantee that we can place the item in the bin that we're currently at, either because the sum was not larger than 10 or we went to the next bin. And what do we do then? We place the item in the bin that we're currently at, and then we additionally add to the sum the weight of the current item. So the sum is always represents then the weight of the current bin and always gets updated if we place an item into a bin. Now that's the pseudocode for the whole algorithm. And because I see maybe this is just some pseudocode, so there is not really some specific format behind it. It's just a pseudocode. Is that clear to you, or do you have any questions regarding the next fit algorithm or the pseudocode of next fit, or is everything clear?
Okay, so maybe just to clear some things up about the pseudocode, because I saw that in the chat. The colon equal is just an assignment. So we assign current bin, the variable current bin, the value 1.
Mm-hmm.
Then here this w underscore I is just from the input. So w1 is the weight of the first item, w2 is the weight of the second item, and wi is the weight of the ith item, so the current item. And yeah, you can do whatever you want basically in pseudocode. So here we just wrote that we place item I in the current bin, and whatever that means in this case.
The definition here is more like a mathematical definition. That's why we've chosen this way. So in mathematics, maybe you have seen that if you define something, you also write it this way.
The n is not defined, but it's from the problem definition. So n is just the number of items from the input.
But you're actually right, we should add this to the input. Yeah? So I will do that when we upload the slides. Yeah, and maybe that's a good question. Why do we need a bin here, or why do we need to consider this problem? I mean, that's a problem that you encounter also in reality. Probably not in that abstract way, but for example, if we want to send packages somewhere, so in real life now, and you want to transfer them, I don't know, from Vienna to Berlin, yeah, and now you want to pack all the packages into, I don't know, larger containers, and you also want to minimize over the containers, that you do not, I don't know, put one package in each container, which is very inefficient, but rather minimize over the number of containers.
Because you want to send as much packets as you can with as little containers as possible.
Or maybe we can put also phone books into or pages of phone books into the bins. Okay, but I have the feeling that next fit is clear. So we go to the next algorithm, I think. So, we have the quiz. We have the quiz left. So this is an instant of next fit now, where n is 6. You have the weights 1, 2, 4, 3, 5, 3, and the maximum capacity in the bin of 6. And yeah, maybe think about it. How many bins do we need for this instance? If we apply the next fit algorithm, we should mention this. You apply next fit, not some arbitrary algorithm, not the optimum solution, but really next fit. But probably I haven't said that in the beginning, why we get some wrong answers.
But I see many correct answers.
Yeah.
Yes.
Should we show the answer? Yeah. So the solution is, of course, that we consider the first item, we pack it in the first bin. The second item gets packed also in the first bin.
Because now there's a capacity of 3 so there's a weight of 3 in the bin, and it has a capacity of 6, so that works.
And if we put in 4, then we would have 7.
Which is too much.
So we place it in the next bin. If we then consider 3, 4 and 3 is 7 again, so we have to place it into the next bin. 3 and 5 would be 8, it's also too much, so 5 is in the next bin. And then there's this 3 remaining, 3 and 5, doesn't fit together, so it's in the next bin. And I just want to highlight this second 3 with the star, that you can distinguish those two 3s, because maybe in some other algorithms they appear in a different order then. Okay, that was the part about next fit. Then we continue with our next algorithm.
Yeah. Okay, so I think I already saw this before, but the next algorithm is first read, so I saw it in the chat before. Ideas that come close to this one. Let's again start with an example. Okay, first fit works in a way where instead of just putting the item in, if it doesn't fit into the next bin, we always consider all bins that we already have put items in and then place it in the first one where it fits. So this improves the last algorithm in a bit, so we don't waste that much space. So maybe just start with the example. We start the same as before. We put 5 into the first bin. Then we consider the item of the weight 8. It doesn't fit into the first one, so we put it into the second one. Then, now it differs from the last algorithm. We consider the item 3, and we start by looking if it fits into the first bin. It does, so we can put it into the first bin. Then 6, let's check. It doesn't fit into the first bin. It also doesn't fit into the second bin, so we have to put it in the third bin. Now let's consider the next item. 4 doesn't fit in the first, doesn't fit in the second, so we put it into the bin with the 6.
That's fitting perfectly there.
So now let's consider the 2. This does fit into the first bin, so we put it there. And then the 7 doesn't fit in any bin we used before, so it gets put into the fourth bin.
So did we improve over the last algorithm right now?
Yes, so I think if you look at next fit, we used all 5 bins. Of course, we could have used more, but we used 5 bins in next fit. And now with first fit, we only needed 4.
That's really cool. So we saved 1 bin, so we do a better job at minimizing.
Yes.
And also this observation is true, of course. It's slower now because we always have to go through all bins that we already created. And it's more optimal. Yes, in some sense it's more optimal than before. But one thing here is it's definitely not worse than next fit, because this last phase of first fit, like checking the last bin, and if it doesn't fit in the last bin and then creating a new bin, is the same as you do in next fit. So first fit cannot be worse than the next fit. Okay, we also look on the pseudocode, I think, at next. So we go back here and we go to the pseudocode now. And again, we have the same input. And as mentioned before, we should also include the n into the input. And now I've written it a bit differently, the pseudocode. And we just say now for each item I, we do something. So implicitly we say we do it for I equals 1, I equals 2, until I equals n. So, but now we just we do this implicitly here. And also for all bins, we call them B now, we do something. And what is it? If the item I, so the item that we are currently looking at, fits into the bin B that we are currently looking at, then we place the item into this bin. And if we do this, then we do not have to consider all the remaining bins that may be available, but we can go directly back to line 2 and start with the next item.
So we just don't go to line 2, we also consider the next item, of course.
So that's maybe I should have written this in a better way. Yeah, you're absolutely right. So this is the first option, that when we iterate here over the bins, that we find some bin where we can fit the item. And if this is not the case, so the item I did not fit in any bin, then we create a new bin. Again, we can call it B. Then we add bin B to the other bins. So maybe we have a list of bins maybe, and we add it there to the list of bins, and then we place it into this bin. And then we can continue again with the next item.
So as you might already see, this algorithm now needs more computation than the last one, because for each item now we consider each bin, and in the last algorithm we just did something for each item. Yeah. So we didn't have the second loop.
So this is like more complex now. Maybe the pseudocode is now, the pseudocode is some mixture now out of doing it in a very simple way that you can understand it, but not going into detail, like implementing it in C, which we will see later. So it's like a mixture of both of them. And of course, explaining the idea is probably easier than understanding the pseudocode. That's why we do both of them. And maybe you try to think about the pseudocode and doing an example, maybe then it gets more clearer.
So what would you need to do to ignore bins that are already full? You could do that, but then you would have to maintain a separate list of bins that are not already full that you can search through. So that's a complex question, I think.
Yeah, but it probably does not change too much in the long term, because in general you are probably not able to really make the bins really full. You often have like 1 or 2 left. Okay, then maybe we also go to the short exercise. So it's the same example as before. You again have those 6 items, you have the capacity of 6, and now the question again is, how many bins do we need if we apply first fit to this example? And how many bins did we use for next fit? It was 5? Was it 4?
5.
5, okay. Everyone says it's 3. Someone says it's 4. So it's still interesting. Maybe we wait for some more answers. The first algorithm was next fit, and now this is first fit.
So in the last algorithm, we also always try to fit the item in the next bin, and now we always try to fit it in the first bin that fits.
Okay, it seems like 4 is dominating the 3, so let's see what the solution is. And the solution is indeed 4. Yeah, so most of you are right. Just go through it again. So the 1 can be put in the first bin. The 2 also fits into the first bin. Now the 4 doesn't fit into the first bin. Again, 4 plus 1 plus 2 would be 7, which is too large. So we put it into a new bin. The 3, and now if we consider the 3, then we see in the first bin 1 plus 2 is 3, and the 3 equals then 6, so we can place it there. Then we have the 5, so the first bin already has the value 6, doesn't fit. 4 and 5 is larger than 6, so we have to create a new bin where we put the 5. And then when we consider the second 3, then this bin is full. 3 and 4 is 7, 3 and 5 is 8, so it needs to be put into a separate bin. So the solution is 4. Okay, and now we have one more improvement, I think.
So, any improvements? And I already see some in the chat that are very interesting. So maybe let's look at it.
Yeah, so this was also the first idea of most of you.
It's called first fit decreasing. And if you already know how first fit works, it should be pretty simple, but let's have a look. So maybe this already spoils it now, but we sort the items. We sort the items before applying the algorithm. So we consider the big items first, and this would always try to fill earlier. To put the bigger items in first. So let's try this out. Okay, so let's put the 8 in the first bin. Then we have the 7, doesn't fit, so we put it in the second bin. 6 also doesn't fit in any of the 2 bins, so we put it in the third. Then the 5 also doesn't fit, so we put it in the fourth. Then we have 4, which fits here. So
why do we place it there?
So it doesn't fit here, it doesn't fit here, so we put it in the third bin, the things. Then we have the 3, which fits in the fourth bin. And then we have the 2, which also fits here. So I just skipped it, but the 3, oh no, wait, I did something wrong. Okay, the 3 fits here, sorry. And then the 2 fits here.
Exactly.
I accidentally did next. The first fit without sorting, I don't know. So... Okay, maybe because it's a bit quick now. So
this was the state.
So this was the state before I did something wrong. We take the 3, look at the first bin, it doesn't fit. So we put it in the second bin because it does fit here. And then when we consider the 2, it does fit in the first bin, so we put it in the first. Okay, now it's correct.
Yeah, and now luckily everything is perfectly full now in the first 3 bins.
So if we look at compared to first fit, in both we just used 4 bins, but maybe we could say that with first fit decreasing, we use them in a more efficient way because the first 3 are completely at capacity, and the fourth, and with first fit we had some holes before. Okay,
then we switch back to the slides and we switch back to the pseudocode, which now really gets complicated because now that's like the most complex algorithm. So we really have to do a lot of things here in the pseudocode. So let's look at it. And it looks like this. Okay, it's not that complicated. So we just sort W1 to Wn in the first step in descending order. And then to this sorted W1 to Wn, we apply first fit, which we have already seen. So that's the whole pseudocode. So I can make my life very easy in this case because we have discussed this already. I'm not 100% sure, was a sorting algorithm discussed in the lecture?
I don't think so.
Okay, then the first step is maybe a bit more complicated to you, but at least the second step with the first fit is now completely clear because you can just use the implementation of first fit. Okay, yeah, I think it was just search algorithms. Then now a very large surprise, we again have an exercise for you and it's again the same instance, and now we again ask how many bins do we need for that instance.
Maybe this is the example we need to see that first fit decreasing is actually more efficient than first fit. Or maybe not.
Or maybe not. So the bins are now 3, but we wait a bit because we have a 4 as well. We have some more. We have 2. We have a 2 actually here. Okay, maybe there was some sorting algorithm in the first lecture. Yes, so you have already one. Okay, there are some more 4s, there's some more 2s.
It's pretty mixed.
I think maybe 3 dominates, I don't know. So do we have a look on the solution?
Let's look at the solution.
Okay, and the solution is 3 bins. Yeah, why is it the case? So we sort them in descending order, so we get the new vector of weights. And then we start with the 5, place it in the first bin. The 4 doesn't fit in the first bin, so we put it in the second bin. The 3 does not fit neither in the first nor in the second bin, so we create a third bin. But now our second 3 fits into the third bin. Our 2 doesn't fit in the first but in the second bin, and our 1 does fit in the first bin, so we really get now a solution which only contains 3 bins. One remark on those who said it would be able to put it into 2 bins. This is not possible because if you already sum over the weights of the items, then this is definitely larger than 12, and 12 is the maximum that can be put into 2 bins, so we definitely need 3 of them. Okay, that were those algorithms, and as we're really good in the time, I want to ask now a question. Do you believe that this first fit decreasing algorithm produces the optimum solution? Because in our example that you have shown us, this was the optimum solution, and also this is the optimum solution. Is that true, or could it be that the first fit decreasing does not produce an optimum solution?
There are many no's.
Okay, so there are many no's. I give you the solution. No, it's not optimum. So you can create an instance where the first fit decreasing doesn't produce the optimum solution. And maybe if you want to think about this a bit further, you do as a homework, think of some instance where the optimum solution is better than the solution that you obtain from the first fit decreasing algorithm.
So, of course, it should be best for minimizing the number of bins and not for speed of the algorithm.
Yeah. And another question I have, if you compare the next fit and the first fit algorithm with the first fit decreasing algorithm, there is some difference or some large difference between those two and the first fit decreasing algorithm, which I don't know whether it's very obvious, but there's really an important difference. Why, and that's also might clarify why someone would use next fit or first fit instead of first fit decreasing. Because for some applications you cannot use first fit decreasing. So you have the speed answer and the sorting answer. Yeah. So we can basically say that speed doesn't matter too much because they are all very close, but the sorting step might be a problem, because think of the example from before where you have the packages, and you probably do not have all packages at the beginning because they will get delivered to your post office, and so you can't sort them because you don't have them at the beginning. So you really have to get them, you see them, and have to place them right away. So you cannot do this sorting step. So for that reason, next fit and first fit also are used or can be used, and first fit decreasing cannot be used in this case. Okay, this was just some background information because it's a really exciting topic. So it might be just one thing. If you're interested in the master program in computer science, you can encounter some of those problems, which are really fun, and I'm currently studying that. Okay, now continue with the next part, because now we go to C. So I take it.
Okay, so we saw all these algorithms now, but we are programming lecture, so let's look how we can implement these in C. But we need a few more things to learn in C so we are able to implement them.
Mm-hmm.
So let's start with a bit of stuff about C. So first we need comparison operators. As the name implies, they are used to compare two variables, or like also just literals, numbers, floats, etc. So there are these. So you have the equal operator with it's just two equal signs, which checks if two numbers are equal. Then we have the exclamation mark equal sign, which means not equal. Then we have the greater than sign, which means greater than, and a greater than with an equal sign means greater than or equal. So I think this is pretty easy to remember. And also we have the less than sign and the less than and the equal sign for less than or equal.
Mm-hmm.
Exactly. I think this should be pretty straightforward. So let's just continue. So now we also have logical operators. I think you've already learned about them in analysis and maybe in foundations of computer science. So these are and, or, and not we'll cover now. So and is expressed with two ampersands and is true when both sides of the operator are true. Then we have the or, which is true when one or both are true. And then we have the not, which just makes true to false and false to true. I think you should already know them. So yes, and the not is the exclamation mark, and the or are these two vertical lines. Yes, and now we can also see that the not equal is just the not operator with an equal sign.
So it makes kind of sense to use it this way. So what can we do now with those operators? And you have probably already seen them. They use them in today's lecture. Probably you have also seen them in Python, which are conditions now. How do we write such a condition? So we have here if as a keyword, and then in brackets we have a condition, and a condition usually consists then of the operators. So we want to compare some values, or we want to compare values and compare some other values, or we do some checks here. And in the case that this check is true, returns true, then we execute the code which is in the block which follows after the if statement here. I should not type in there. So if this condition is true, then all statements in the code block are executed. So this is just a simple if, And then we can also combine it with the else. So we have here again the if with the condition and some code that should be executed, followed by an else, and again a block with some code contained in it. And now if this condition evaluates to true, then the code in the if block should be executed, and otherwise if the condition evaluates to false, then the code in the else block should be executed.
So it's really like if you're just saying if this, then do that, else do that.
Okay, I'm very sorry. The poor keyboard. So again, to summarize it, if the condition is true, then the if block is executed, and if the condition is false, then the else block is executed. Okay, then continue, please.
Then we have something now you already saw in the pseudocode before, which is a while loop. It's basically a condition which repeats the body while the given condition is true. So it's like the if, but it repeats as long as this condition is true. So this also means if in the body here of the while loop you don't do anything that changes the condition to false, it will run forever. Yeah, so I think that's it for the while loop. Are there any more questions to conditions or while loops before we continue?
Yeah, so like an if loop, that's probably two words you shouldn't use in the same sentence.
No.
Because if is not a loop.
Yeah, so in an if the condition is checked once and then the code is executed if it is true, else the else block is executed. And in a while loop, the condition is checked multiple times. And if it's true, then the block is executed as long as the condition is true.
Okay, yeah, no question at this point.
Then let's continue with arrays. To implement bin backing, we need some sort of way to store the items and the bins, and so we don't have to create that many variables. We'll use an array. Arrays are like a list of elements of the same type. In C, there are fixed size, and you can access the elements of an array like we did in the pseudocode by its index. Let's look at it. You can create an array by writing type, the name of the array, and in the square parenthesis the size. And you can initialize it by writing the equal sign, so we assign basically a value to it, and then in the curly braces we separate each element with a comma. Maybe it is a bit more clear with the example here, so we can create an array of integers with the length 5 and then assign this list of numbers to it.
So this array contains then 1, 2, 3, 4, 5 basically.
Exactly. It's fixed size in it. You can't change it after you chose it. So it's not like it's always the same size, but the size is fixed while you compile the code. You can't say, okay, I'll add an item to that array after you created it because it's a fixed size. Okay, so accessing array works by providing an index, and this works also with these square brackets. And as was said in the lecture before, the index starts at 0. So if we create this A now, this array A, and we write those numbers in it, then we can access the element at index 0, which will be the first element. So B is 1 here. Then we can access the element at position 2 or index 2. This will be the 3. So actually the third element, because this is the 0, this is the element with index 0, index 1, index 3.
2.
2 with the value 3. And now if we want to access the last element of an array, we need to take the size and subtract 1 to get this 5. This is because the array starts with indexing with 0. So the last element is the size -1.
Then one question was if there is some append function in C to add an element. That's just in Python. So in C it will be a bit more complex to do that, but we will see that in the course.
Yeah, of course there is a way to create lists with a variable number of items that you can change later, but it's not arrays when you use them like that.
Yeah. And also you cannot use -1 or -2 for the last or second last element. This is also something which just works in Python. So you really have to calculate the size, or you really need to consider the size and subtract 1 from the size.
Maybe we'll get to why that doesn't work in the next practical stream.
Yeah? Okay, so should we continue now with the Menti questions about that, or do you really want to start right away with the bin packing implementation? We have 8 minutes left.
I think we should start with the implementation.
Yeah.
And yes, so an array with size 0 really has no items. So providing a size for array is still normal. If you put in a 3, you have 3 items, just that the last item is at index 2 and the first one is at index 0.
So the Menti questions will be the recap for next week. No, not for next week, for in 3 weeks.
Yes.
And we will now do also some demonstration of one algorithm in C, because I think that's
exactly
more important than the Menti question.
So, okay, let's try implementing bin packing in C. We will use the next fit algorithm. So the implementation is a bit easier. First, let's specify how many items we have. I'll use the same example as I did in the drawing. So we have 7. Then let's create an array with size 7 of integers to store the weights. So I will call these items. And then I have 5, 8, 3, 6, 4, 2, 7. I think those were the weights.
Yeah, that's also the instance from before.
Yeah, so it's the same as before. Then let's specify the maximum capacity for a bin, which is 10. Same as before. And now let's just create an array with bins where we'll place the item. So because we can't change the size of the bins later, if you want to create a bin, let's choose the 7 as the size, because we definitely won't need to create more than 7 bins for 7 items. And let's put 0 in all of those spots. So because we have 0 items in them, we will be counting the weight of how much weight is in this bin afterwards.
So this is basically the sum that we used in the pseudocode, but we will now really do this separately for every bin to demonstrate it more clearly.
So you can visualize it better. Now let's start with the loop. So we have the while, and now we need a way to check, to iterate over every item. So let's increase a variable current item as long as it's smaller than n. So let's create it. We initialize it with 0 because we start with index 0, as said before, with arrays. And also we need to go to less than n and not less or equals to n. So this would be wrong, because we would be accessing an item that's not in the array. This is a side effect of starting with 0. And the last thing in the loop, of course, is that we increase current item by 1. Let's just do it like that. There are, of course, shorter ways to do this. Maybe you know them from Python. Okay, now we need a second variable to keep track of in which bin we are, because we need to know, okay, in which bin am I, so I can check if my item fits there, as I will choose the next bin. So So the current bin always stores the index of the bin we are currently using. So now it's 0, so it's this one. And the current item also has the index. It's 0 at the beginning, so we'll first consider the first item. Okay, this was our first while loop. Now we need to check, does the item fit into the bin? So let's write an if. And, okay, what should we do now? We need to get the value of the current bin, how much weight already is in there. So let's do bins, the array of the current bin. So we access the value of the current bin here. And add the weight of the current item. So this is right now at the first iteration, this would be okay. We have 0 here because there's nothing in the bin, and we add 5 to it. And let's then check if this is less or equal to capacity. So if you remember, capacity is how much we can fit in one bin. If it is less or equal than capacity, then we can put the item in the current bin. So item. I'll write it like that so it's more clear. So we assign to the current bin the value of the current bin plus the value of the current item. So we put the item into the current bin. Now I'll be a bit lazy and we'll also output something, but I will just copy that. Okay, here I'll just output, okay, the item with this index, with current item, with the weight. So we do items current item, fits in bin, and then we print the index of the bin. So we see what's going on. Now let's write an else statement, because what should we do if the item doesn't fit in the bin? Then we would need to consider the next bin. So we do current bin equals current bin plus 1. So we increase the value of current bin by 1. And now we also need to add this item to the next bin, the bin we basically just created, because we are sure it's empty, the new bin we have, because in next fit, the next bin we consider is always empty because we haven't considered it before. So we do bins, current bin, and add items, current item. So this would not be needed right here. We could just write bins, current bins equals the weight in this bin equals the weight of the current item. But just for clarity, I will add this here so that it's more clear that here and here basically the same thing happens. Now I'll also copy the printf here. So I'm printing just exactly the same as before. We could also do this after the if, but yeah. Then let's just output some new lines so we can see when a new item is inserted. And maybe let's try it out. You don't know yet how to compile and run a program. We'll get to that at a later point. Right now, I just have to type make to compile and run it.
So what you can do, we will of course upload the source code, and if you don't know how to run it on your own device, you can just copy the code into online GDB and run it there. This would be probably the easiest thing for you.
Yeah. Okay, so we can see items get placed in some bins. I have prepared some function to print these bins little bit nicer. I'll just copy that in. You don't have to worry about what this does for now. It's just so we can see what's in the bins.
Okay, so it's just we keep it as a better printf for now, which does something more than just an ordinary printf.
Okay, as you can see, it outputs what items are in which bin. Just like that. Okay, so we can see the 5 gets put in the first bin, then the 8 in the second one, then the 3 gets inserted there, then the 6 goes into the third bin, then the 4 gets put in the fourth bin, the 2 as well, and then the 7 gets put into the fifth bin. Exactly, and now we already implemented our first little algorithm in C.
Of course, I mean, you really did this like straightforward. You had more or less the pseudocode implemented this way, and it's absolutely no problem if you cannot do this at this moment on your own, because we already use rather more complex concepts like arrays, loops, and conditions. So if you feel maybe a little bit lost, if you consider that you implement this at some point, this is no problem. The important thing that you understand what we were doing right now, and probably in 3 or 4 weeks you will be able to do this on your own, and we will also show you how to do it like in more tiny steps during implementing such a large program, but now for the first algorithm we wanted to show you something more complex in the beginning.
Okay, so this was Next Fit, exactly. And if you would like to do some exercises at home, because we have 2 weeks of no stream now, you could take this code, which I'll upload in the handouts as always, and maybe try printing the number of used bins at the end. This could be a fun little exercise. If you want something a little bit more challenging, you could try implementing first fit with the pseudocode we gave you. Maybe try writing some C. Or if this also was easy, you could try implementing a sorting algorithm and then implement first fit decreasing. These are some suggestions for exercises you could do on your own.
So I have learned something from the last stream. This was now a tongue twister, right? Yeah, okay. I have not seen too many questions right now, so I think
So I hope it's pretty clear and not overwhelming.
But yeah, if you have any questions, like in 2 or 3 days, you have a look on the code, feel free to ask him on Discord, and we will also answer them very happily.
Yes, we're always happy to answer questions on Discord, especially about programming. Yes.
Okay, then maybe we just summarize what we have seen today. It was really a lot. So we started with this bin packing problem, where we first had some example, the first idea, where you really got to the right idea with this decreasing thing, and we also saw those pseudocodes and examples. And then we went over to C to see these logical operators and comparison operators, which we need for the conditions that appear in an if or in a while loop. So we touched a bit C, and then in the end we also showed and demonstrated you how to implement a more complex algorithm in C.
Yeah, we implemented bin packing in C quite fast, but I think you should be able to read through the code and understand what it does with the things we provided to you. As you said, writing this on your own is a bit more difficult, or quite more difficult than just reading through it and understanding it.
And if you download the source code, which we will offer, and you want to try something, don't hesitate to do that. Just change everything that you might think you need to change, and compile it, run it in online GDB, and see what's the outcome. You cannot do something wrong. And just try everything, and in the best case you learn something from that.
Just play around with it. Exactly.
Okay, then we go to Menti. So you can already switch to Menti, and we have
the questions.
But we need to find out who was the winner of today, out of the first 3 questions. And again, there is no animation, whatever, but the Zug won today's Menti, so congratulations, and thank you for participating. And next time there will also be a Menti.
Okay, now it's your time to ask questions.
as there's the question, can we apply to the next coding sessions yet? So you can only apply to once for a block, and currently there's the first block. So if you have been to the coding sessions yet, you cannot book another slot, but we will offer that probably next week or in latest in 2 weeks for the second block.
Do we have to have 50% on each out of the 3 assignments in order to pass? For example, what happens if you get 30% in one assignment? No, you don't. You have to have more than 50% of the points in the practical part, so in the KU, but also on the last assignment, there are some more requirements which you need to fulfill in the last assignment to pass the course.
Yeah, I will come to that
Yes.
at the time. Homework 2, it will be published. I don't know when exactly, but we will announce it on Discord.
So make sure to join our Discord.
So for homework 2,
I don't think it's possible in flowcharts, but you also don't have to do it in pseudocode. You can maybe just, I don't know, describe it in some sentences, or maybe do it in a more mathematical way, or maybe also just create some bullet points where you go step by step through your algorithm. I think all of that would work.
And the publishing date is planned to be tomorrow at 6 p.m. Is there a manual to configure the VS Codium?
I think in the virtual machine, everything should be configured the way you need it. But also, I think it's not really difficult if you need to change something because something annoys you. You can find it out pretty easily on Google.
And how to then run your program, compile your program, and run your program, that's something that will come up in the next practicals.
No, I don't think so.
And I honestly don't know what's the content of the first assignment right at this moment. When I have already had a coding session, I don't need to register for a new one, right? Exactly. So
not yet.
Not yet. So if there is the second block, so I will announce this on Discord, but when the second block is published, then you can register for a coding session in the second block again.
Genau. So exactly as we said, you can use online GDB. We linked it in the last handout and in the last showed it to you in the last stream. There you can just compile and run C online. Maybe you can just open it.
Yeah, of course.
Exactly, you can just open it. You already have your main function with your printf here. If you press run, you will see that you need to select a language. You can just select C and then run your program and you will see the output. I think this would be the easiest way for you right now to try out C and maybe also try the algorithm we wrote today.
Yeah. So because there's the question about the coding sessions, there will be 4 blocks and you get points for the first 3 registrations. So if you don't have time for one block, you can skip one block. Any name? Why? Okay, so any reason why the TO class prefer a VS Codium or VS Code?
I think that's some...
I didn't get it.
Yeah, it's just some rather complex stuff I think you should think about on your own.
I think we answered that. So currently not.
You don't have to code, but you have to write an algorithm or at least describe an algorithm.
That's...
I think so.
If I may comment by code. You said that that it's probably more description than really writing code.
Yeah.
Since we don't start directly with C this semester, will the programming assignments be a bit simpler than last year?
No.
Probably not. No.
So we just delay starting with C a little bit, so maybe you can get a better feel for how to think when you program. So maybe you learn that a bit and how to think about algorithms, and you get a deeper understanding of how computers and memories work before you directly jump into C and try things out.
Yeah, and in addition, we assume that some other courses teach the basic concepts already, that we can really start in November and dive really into C and don't need to explain everything from the beginning. Okay, I was in a programming session on Tuesday at 11. I forgot to do the report and did it today at 5 because you've mentioned it. Is that bad? It's 2 days and a bit, so maybe that's still okay. So we will have a look on that, but maybe for the first block that's still okay.
I don't think so, because the coding sessions are meant for you to also do some stuff there. So it would be pretty good if you had if you had some stuff where you can code in the coding sessions.
Yeah.
But there are also computers in the rooms where the coding sessions take place, I think.
Yeah, but probably there is not the virtual machine, for example, installed. So it might be a bit hard. So the best case is really if you bring your own device.
Yes.
Yeah, should be fine. Yeah, so the official homework will be published tomorrow, and we today announced some voluntary exercises that you can do to continue with the code you already implemented, or do the voluntary exercises that we offer.
Yeah, and I think the last part of the lecture, they talked about the homework a little bit.
Yeah, that's true. What do you think?
Just practicing enough and always trying to understand everything that's like presented in the lectures and in the streams and also in the other subjects. So try not to fall behind.
Yeah, so really practice. Practice a lot. Maybe do the exercises.
Yeah, also maybe try stuff out on your own that you see in the lectures, because that always helps. And maybe you have some problems, maybe it doesn't work, and that's when you will learn most.
But that's really a good question.
Anything in that?
Yeah, there are some questions instead. Do we need our credentials when we take the exam? Yeah, so you will get an info about the exam like two weeks before, where you see everything that you need to know for the exam.
Yeah. Also at the exam you are allowed to use your phone for the two-factor authentication.
Yeah.
You will need.
Because you need that, yeah. Okay, one more question appeared on Menti.
How do I get to it?
With enter. That should be, yeah.
Where can we see the points we get from the homeworks, coding sessions, etc.?
Yeah, it's a little bit work in progress still, so I have to do that, and yeah, you will see them on our course website, or a link to our course website.
Where you just have to log in with your TU Cards credentials, and then you will see your points and also comments the tutor wrote for your assignments. Yeah, right now we still need to assign students to groups and everything. When your first assignment starts, we'll have those groups, and also you'll get your grading for other stuff. Yeah,
but in general, for the homeworks, we will need probably 2 weeks to grade them, because we have, I think, 640 submissions, and yeah, for the coding sessions, if you have done everything properly, you can assume that you get 3 points.
Yes, and you will be assigned to a tutor with the first assignment.
Yeah. Because now if we would do that right now, then maybe there are some groups where 10 people do not continue with the course, and other groups there are like only one who is not continuing, so that we would not have an equal distribution there.
Thank you.
Danke, Lukas.
Okay.
Yeah, I think
that was it.
That's it. So we switch back, I think, here. Yeah, okay. So have a nice ending of the week. Do not forget to do homework too. And yeah, for the next 3 weeks, try it really to practice a bit, that you do not lose track and that you're really prepared for the next streams, where we really dive into C then and really only do C.
The code part won't get any easier, so really try to practice.
Okay, then have a nice evening.
Bye.
Bye.